Alright, let's start. Number 9. Strange matter. Everything you've ever touched is made of two types of quark, up and down. Every atom, every star, every person. Two flavors doing all the work. But inside a neutron star, where gravity crushes matter beyond anything you can picture, a third flavor appears. Strange quarks. And some physicists think that when you mix all three in equal parts, you get the most stable form of matter that can exist. More stable than iron. More stable than anything on the periodic table. If that's true, every atom in your body is temporary. A ball on a shelf. Fine until something bumps it. That something is a strangelet. A fragment of strange matter, potentially smaller than an atom. If one touches ordinary matter, it converts it. The energy release converts the next layer, then the next. Chain reaction. No off switch. Just a wave of conversion rewriting everything it touches into more of itself. Neutron star mergers, which we've confirmed are real, are violent enough to spray core material across the galaxy at near light speed. Seeds of the most dangerous substance imaginable, scattered like shrapnel. When the Brookhaven Collider turned on in 2000, people genuinely panicked it might create strangelets. Same fear with the Large Hadron Collider in 2008. Scientists searched lunar soil with mass spectrometers. Found nothing. Now here's the honest cut. Strange quarks are real. We see them in accelerators. But the hypothesis that strange matter is the true ground state of all matter is unproven. Everything about strangelets converting planets is theoretical. And there's a strong counter-argument. If strange elites were stable and easy to form, they'd have converted every neutron star in the galaxy by now. Old neutron stars still have normal crusts. That's good evidence the worst case doesn't happen. But probably doesn't happen and can't happen are different sentences. And the hypothesis is still open. Strange matter rewrites atoms. The next theory rewrites what atoms even mean. Number 8, the Bekenstein bound. This is probably my favorite one on the list. There's a maximum amount of information that can fit inside any region of space, not because of technology, because of physics. The universe has a storage limit. In 1973, Jacob Bekenstein figured out something that broke everyone's intuition. A black hole's information content isn't proportional to its volume. It's proportional to the surface area of its event horizon. Double the radius and you don't get 8 times the storage. You get 4. Information scales with the surface, not the interior. Reality stores data like a hologram, not a filing cabinet. 2 physicists took this to its conclusion in the 90s. If all the information inside a volume of space can be described by data on its boundary, our 3-dimensional universe might be a projection from a 2-dimensional surface. This is the holographic principle. And in 1997, it got a concrete mathematical foundation that's now considered one of the most important results in theoretical physics in 30 years. Seth Lloyd at MIT calculated the total computational capacity of the observable universe, about 10 to the 120th operations since the Big Bang, 10 to the 90th bits. Enormous numbers, but finite. There's a maximum number of distinguishable states the universe can hold, a maximum number of possible configurations, a maximum number of possible U's. The universe isn't a stage, it's a hard drive with a file size limit. And your data on it, that last part is philosophical extrapolation. The Bekenstein bound itself is established physics, but the vertigo is real either way. The vertigo is... And if reality has a storage cap, that raises a question about what happens when you try to outlast it. Number 7. Quantum immortality. Under one interpretation of physics, you can never die. That is not the good news it sounds like. In 1957, Hugh Everett proposed that every quantum event branches the universe. All outcomes happen, each in its own branch. This is the many worlds interpretation, and serious physicists take it seriously. Max Tegmark designed the thought experiment, a gun wired to a quantum random number generator. 50-50 every second. In standard physics, you eventually die. In many worlds, every second produces a branch where you survive and a branch where you don't. You only ever experience the surviving branches. Click, click, click forever. Philosopher David Lewis called this the terrifying corollary. Every cause of death is quantum mechanical at root. A blood vessel holding together depends on quantum bonds. Under many worlds, you should expect to survive whatever you encounter. There will always be a branch where you made it, Lewis gave that lecture in 2001. He died of heart disease 4 months later. Now, Tigmark himself pushed back. Death isn't binary. It's gradual. There's no clean quantum split. And a physicist published a formal refutation showing that the quantum measure of surviving branches drops exponentially. Survival becomes negligible. But negligible isn't zero. And the nightmare goes like this. You survive every crash, every disease, every organ failure. Barely. Always barely. The most damaged version of yourself that still counts as conscious. Everyone you know dies in their branches, centuries pass, you're alone, and you can't stop. Everett reportedly believed it. His daughter referenced it in her suicide note, wanting to join her father in the right parallel universe. The horror isn't death. It's that death might not be available to you, but everything so far has been physics happening to you. The next one is the first where the threat is intentional. Number 6. The Dark Forest. The universe is full of civilizations, they're all pointing weapons at each other, and we just turned on a flashlight. The logic starts with 2 axioms. Survival is the primary need of every civilization, and civilizations grow, but total matter in the universe is finite. Add the chain of suspicion, you can never verify another civilization's intentions, and they can never verify yours, infinitely. Add technological explosion, a harmless civilization can become an existential threat in centuries. On cosmic timescales, that's nothing. The conclusion drops out like gravity. The only rational move is to destroy on detection, before they do it to you. The universe is a dark forest of armed hunters. The ones you find are the ones who made a fatal mistake. We've been broadcasting radio for over a century. Our signal bubble is about 200 light years wide. The Milky Way is 100,000 across. We've been visible to roughly 0.00004% of the galaxy. In 2015, Hawking and others signed a statement cautioning against actively sending messages. There's a fair critique. An economist argued in 2024 that the forest can't be dark because advanced civilizations could survey every star system through gravitational lensing. You can't hide if you have a star. But if the dark forest is real, a kinetic impactor the mass of a school bus at 99% light speed hits with the force of thousands of nuclear warheads. You'd see it as a faint blue shift for about a microsecond, and the signal telling them where to aim has been traveling outward since the 1920s. What if silence isn't about fear, though? What if every advanced civilization does the same thing and it has nothing to do with hiding? Number 5. The transcension hypothesis. The reason we can't find aliens isn't that they died. They went inward, published in Acta Astronautica in 2012. The argument flips everything about advanced civilizations. They don't build bigger, they compress, migrating into increasingly dense, miniaturized scales of space, time, energy, and matter. The endpoint is a black hole-like computational environment, maximum information density per the Bekenstein bound, maximum energy harvesting, time dilation that lets you run billions of subjective years while the outside universe barely moves. This flips the Kardashev scale completely. Instead of civilizations getting bigger, they get smaller and vanish. Electromagnetic leakage, radio, television should last about 200 years before going silent. 600 years later, near black hole density reorganization, and it's testable. There should be a galactic transcension zone where older civilizations have already compressed, showing a missing planets problem detectable by current surveys. Here's the dark connection. If black holes birth new universes, a real hypothesis from physicist Lee Smolin, then civilizations compressing into black holes might be participating in universe reproduction. Life isn't the point, it's the mechanism. You exist because you eventually make more universes. A compressed civilization would be 10 to the 50th times smaller than its original footprint, and potentially billions of times more powerful. The Dark Forest says civilizations hide and kill. Transcension says they leave, all of them. And if that's the destiny of intelligence, you're on the same conveyor belt. But every theory so far assumes we understand the basic rules. The next one says we might not. Number 4, the Hubble tension. Two measurements of how fast the universe is expanding give two different answers. Both are correct. That's the problem. Method 1. Measure distances to nearby objects and calculate how fast they're receding. You get 73. Method 2. Start from the cosmic microwave background. Run the standard model forward 13.8 billion years. You get 67.4. Both measurements are now precise enough that their margins of error don't overlap. This is not noise. The disagreement is real. In 2025, a physicist at Duke published the most precise distance to the Coma cluster ever measured, solidified the higher number. His words, "The tension now turns into a crisis." It got worse. Data from the dark energy spectroscopic instrument suggests dark energy might not be constant. It might change over time. A study later that year found that time-varying dark energy models fit observations better than the cosmological constant. Here's why you should care. Lambda CDM, the standard model of cosmology, is the foundation of everything. Heat death predictions, expansion forecasts, structure formation, all of it. If that foundation cracks, every prediction built on it becomes unreliable. Over 130 researchers gathered in Greece specifically to address this. No resolution. Every theory before this assumed we know the rules. This one says the rules might have a bug, and if the rules are broken, the next theory explains why that should terrify you. Number 3, the Landauer limit. Every thought you have generates heat. The universe is running out of cold. Eventually, thinking becomes physically impossible. In 1961, a physicist at IBM proved that erasing a single bit of information requires a minimum energy cost as heat, not an engineering limit. A law of physics. No technology that will ever exist can go below it. Verified experimentally in 2012. Every neuron firing dumps heat into the universe. At human scale, nothing. At the scale of a civilization computing for billions of years, it compounds. Freeman Dyson proposed in 1979 that beings could survive heat death by thinking slower and slower, stretching infinite subjective experience across shrinking energy. Eternal consciousness on fumes. Mathematically gorgeous. Then in 1998, astronomers found the expansion is accelerating. Finite, accessible energy. Dyson's immortality breaks. The universe has performed roughly 10 to the 120th operations since the Big Bang. That is its total computational budget. And as it cools toward heat death, the Landauer limit drops, but the available energy drops faster. Eventually, the cost of erasing one bit exceeds all the energy left in the observable universe. No computation possible, no thought, no process that could notice time passing. You already know the universe dies. Here's the part they skip. It loses the ability to know it's dying. Consciousness has an expiration date written into thermodynamics. The lights go out, and then the thing that notices the lights are out goes out too. Number 2, the simulation catastrophe. If reality is a simulation, the moment it shuts down wouldn't look like a glitch. It would look exactly like the laws of physics stopping. Bostrom's argument from 2003. If any civilization ever builds the capacity to simulate conscious minds, the simulated minds vastly outnumber the biological ones. Statistically, you're almost certainly simulated. His trilemma. Either civilizations always destroy themselves first, or they choose not to simulate, or you're in one right now. Pick your favorite. The part nobody talks about. A simulation shutdown from inside is indistinguishable from vacuum decay. The process generating your physics stops, no warning. The warning would require the physics that just ended. Instant, total, undetectable. The Bekenstein bound sets the requirements. Full resolution universe simulation takes about 10 to the 120th bits. Not infinite. A civilization harvesting star energy could do it. And the Landauer limit means they face their own thermodynamic constraints. Running out of energy means shutting simulations down. From your end, that's instantaneous death that looks exactly like a natural disaster. You can't test this. A simulation that perfectly replicates physics is indistinguishable from physics. No experiment exists that could tell you the difference. And the Hubble tension from a few minutes ago, 2 measurements of the same thing that shouldn't disagree, that could be an incomplete model or a rendering artifact. To be clear, Bostrom's argument is philosophy, not physics. The Bekenstein bound and Landauer limit are real. The simulation interpretation is unfalsifiable speculation, but it's speculation that plugs neatly into the physics. And the worst version is identical to something real physicists already worry about. Everything so far has been about threats. The last entry is about capability. Number 1. Weaponized stars. A civilization doesn't need to cross the galaxy to sterilize it. It needs one star and a lot of mirrors. A nickel Dyson beam takes a Dyson swarm, millions of solar collectors orbiting a star, and reconfigures them. Instead of harvesting energy, you focus the entire output into a coherent beam aimed at a target light years away. The sun outputs 3.85 times 10 to the 26th watts. Humanity uses about 1.8 times 10 to the 13th. A nickel Dyson beam channels roughly 20 trillion times our total energy output into a single directed beam. The engineering taxonomy exists in peer-reviewed literature. A Skidov thruster, proposed in 1987, is a mirror on one side of a star that moves the entire system through photon pressure. A Kaplan thruster from 2019 uses the star's own mass as propellant. A star tug from Yale in 2020 pulls the star from the front. The nickel Dyson beam is the offensive variant. The numbers are casually horrifying. Less than 1% of a star's output devoted to beam warfare could sterilize hundreds of planets simultaneously. The same optics that aim the beam work as a telescope. You survey a planet and burn it from the same system without building a single ship. At 100 billion targets in a galaxy, hitting hundreds at once, you sterilize the Milky Way in about 3 million years. One star. A lot of mirrors. A researcher at Edinburgh showed Skidov thrusters would produce detectable transit anomalies. Missions like TESS could spot them. Tabby's star briefly looked consistent with a partial Dyson swarm in 2015 before being explained by dust, but astronomers investigated it seriously. The engineering isn't impossible, just undetected. The Dark Forest said, "Civilizations hide and strike. This is how they strike. Mirrors, lenses, and photons. The same physics that lets a magnifying glass burn a leaf, scaled to a star, aimed across the galaxy. 9 theories. One says the ground state of matter might eat worlds. One says reality has a storage limit and your data on it. One says you might never be able to die. One says the galaxy is a firing range, and we already announced our position. One says every civilization that survives vanishes inward. One says we might not understand how fast the universe is expanding. One says consciousness has a thermodynamic expiration date. One says the shutdown is indistinguishable from physics ending. And one says a single star can be turned into a weapon that sterilizes everything. The scariest part isn't the theory, it's that each one is built on math nobody has been able to break, and one of them says you'll be around long enough to find out which is right.